differentiation in that exercise 1.5. In this lecture, we will find the nth order derivative of the given function. Now, the first function is ax plus b bracket raised to m. So, let y is equal to ax plus b raised to m. Differentiating with respect to x, dy by dx is equal to m in bracket ax plus b raised to m minus 1 into d by dx of ax plus b. So here I use the formula f of x raised to n, or f of x raised to n is its derivative is n times x raised to n minus 1. Now here d by dx of ax plus b is a, because derivative of x is 1 and derivative of b is 0. So what is remaining? A is remains, so derivative is a. So dy by dx is ax plus b bracket raised to m minus 1. Now we will again differentiate this function with respect to x. So now am is a constant, so we can take outside. Then you have to find the derivative of ax plus b bracket raised to m minus 1. Now derivative of this function is m minus 1 into ax plus b raised to m minus 2 into d by dx of ax plus b, because f of x raised to n is n times f of x raised to n minus 1 into f dash of x. So again its derivative is a. So the first a and this again we are getting a. So a into a is a square. Then m into m minus 1, ax plus b bracket raised to m minus 2. This is the second order derivative. Now again differentiating. So d by dx of d2y by dx square. So this ax plus b raised to m minus 2, its derivative is m minus 2 into ax plus b raised to m minus 3 into d by dx of ax plus b. Again the derivative of this ax plus b is a. So this a and a square becomes a cube. M into m minus 1 into m minus 2 into ax plus b bracket raised to m minus 3. This is the third order derivative. So in general, we can write the nth order derivative as here order is 3. So a raised to 3. Then we are decreasing this m every time by 1. 1 m minus 1, then m minus 2. Now here it is 2, but how is this 2 is we can obtain? We can obtain this 2 by order minus 1, that is 3 minus 1. Then ax plus b raised to m minus 3. M minus 3. What is 3? 3 is the order of the derivative. So dny by dx raised to n is a raised to n m minus 1, m minus 2, and so on, m minus n minus 1. And ax plus b raised to m minus n. So we are generalizing this from this third order derivative. Now if you look at this m minus n minus 1, we can write it as m minus n plus 1. Now we will adjust some few terms. The terms are m minus n, m minus n minus 1, m minus n plus 1, m minus n plus 2, m minus n plus 3, and so on. So we will subtract, we goes on subtracting till we get 5, 4, 3, 2, and 1. And at the same time, we will multiply both these terms in numerator. So m, this is the product of the integers, natural numbers which are less than or equal to m. So it is nothing but m factorial. And these are the product of the numbers, natural numbers which are less than or equal to m minus n. So it is m minus n factorial into ax plus b bracket raised to m minus n. Now, if m is greater than n, then this is the derivative of the given function. But if m is equal to n, then what will happen? Then ax plus b raised to m minus m is 0. So, and m minus n is 0 factorial is 1. So we get a raised to n into n factorial. If m is greater than 0 and m is less than n, then d raised to n y by dx raised to n is 0, because it is a polynomial of degree n. It is a polynomial of degree m, and we are differentiating it more than that degree. So its derivative is 0. The second example is we have to find the nth derivative of 1 upon x. So first derivative is minus 1 upon x square. So again, differentiating with respect to x, we will get its derivative as minus into minus 2x raised to minus 3. We can write it as minus 1 square into 1 into 2 into x raised to minus 3. Again, differentiating with respect to x, this minus 1 square 1 into 2, they are constant, so we have to take the derivative of only x raised to minus 3. Its derivative is minus 3 into x raised to minus 4. So again I will combine this minus 1 to in this minus 1 square, so I will get minus 1 cube, then 1 into 2 into this 3, 1 into 2 into 3, and x raised to minus 4. So I can write the general general nth term or nth derivative for this given function as dny by dx raised to n is minus 1 raised to n, 1 into 2 into 3 into up to n upon x raised to n plus 1. Why? How we can write n plus 1? Because whenever there is a third order derivative, we get the fourth power. Whenever there is two second order derivative, we get third power. So one power is more. So dny by dx raised to n is minus 1 raised to n into n factorial upon x raised to n plus 1. Find the nth derivative of the following: e raised to ax plus b. Now differentiate with respect to x. E raised to f of x, its derivative is e raised to f of x into f dash of x. So dy by dx is e raised to ax plus b into a. This a is the derivative of this ax plus b. Now again differentiate with respect to x. Now a is a constant, we can take outside. So derivative of e raised to f of x is e raised to f of x into f dash of x. So derivative of ax plus b, its derivative is a times derivative of x plus the derivative of b. B is a constant, its derivative is 0. So what we get? Only a. So first a, and again we are getting a. So a into a is a square. So d2y by dx square is a square e raised to ax plus b. So again differentiating with respect to x. So this is the third order derivative. Again we are getting a from this derivative. So first a square, and again we are getting a. So a square into a is a cube. So the third order derivative is a cube e raised to ax plus b. So we can generalize this to find the nth order derivative as dny by dx raised to n is a raised to n into e raised to ax plus b. Find the nth order derivative of a raised to px plus q. So let y is equal to a raised to px plus q. Now differentiating it with respect to x. Now here we have to use a raised to f of x. Derivative of a raised to f of x is a raised to f of x log of a into f dash of x. That means derivative of px plus q. Its derivative is only p. So p into log of a into a raised to px plus q. So again differentiating with respect to x, dy dx of dy by dx is equal to p times log of a into d by dx of a raised to px plus q. Therefore d2y by dx square is equal to p into log of a into a raised to px plus q log a. So d by dx of px plus q. So d2y by dx square is equal to p square log of a bracket square into a raised to px plus q. This is the second order derivative. Now again we will differentiate this function with respect to x. So we get third order derivative. Now p square log of a bracket square is a constant. So to differentiate only a raised to px plus q. So again we will use the formula a raised to f of x. Its derivative is a raised to f of x into log of a into d by dx of f dash of x. So d by dx of px plus q. Again we will get only p. So p and this p square becomes p cube log of a bracket square into log of a, we get log of a bracket cube into a raised to px plus q. So from this we can generalize the concept, and the nth order derivative we can write it as dny by dx raised to n is p raised to n log of a raised to n into a raised to px plus q. The next example is find the nth derivative of the following log of ax plus b. Now as y is equal to log of ax plus b, after differentiating it we get d by dx of log of ax plus b as 1 upon ax plus b into d by dx of ax plus b. So here we are using log of f of x is 1 upon f of x into f dash of x. So 1 upon ax plus b into d by dx of ax plus b. D by dx of ax is a, and d by dx of b is 0. So we get dy by dx as a upon ax plus b. Again differentiating with respect to x, a is a constant, so we can take outside, and derivative of 1 upon ax plus b is minus 1 upon ax plus b bracket square into d by dx of ax plus b. So its derivative is a, so this a and a, it becomes a square, and this minus 1 is there, so minus a square into 1 upon ax plus b bracket square. So d2y by dx square I can write it as minus 1 into a square into ax plus b bracket raised to minus 2. Again differentiating with respect to x, d cube y by dx cube is equal to minus 1 a square into minus 2 into ax plus b raised to minus 3 into a. This a is the derivative of ax plus b. So what we will what after simplifying, I can write it as this minus 1 and this minus 1. So minus 1 square, a square into a is a cube, then this 1 into 2 is 1 into 2, and ax plus b raised to minus 3. So from this third order derivative we can generalize the nth the formula to find the nth order derivative as yes, here 3 we are taking 2, so n we are taking n, so we have to take n minus 1. Again here is 3, here is also 3, so a raised to 3, then here 3, so product of first 2, here is n, so product of first n minus 1 numbers, then ax plus b raised to 3 minus 3, so here also ax plus b raised to minus n. Now here there is a product of n minus 1 natural numbers, so it is n minus 1 factorial, and we will take using laws of indices it is this term in the denominator, that ax plus b bracket raised to n. So this is the derivative of log of ax plus b, this is nth order derivative. In this formula we can put the value of n to find particular derivative. If you want a 10th derivative, I will put n is equal to 10. If you want 100th derivative, I will put n is equal to 100. Moving further, the next example is the nth derivative of the following cos x. We have to find the derivative of cos x. Y is equal to cos x, so d by dx of cos x, its derivative is minus sin x. Now if we differentiate, if we goes on differentiate this function, alternatively we will get the cos x sin x, cos x sin x, cos x sin x, and finally we are not able to write its nth order derivative. Okay, so we have to keep only one function at each and every step of the differentiation. So what we will do, we will write this derivative in terms of cos, as it is minus sin x, so I will write it as cos of 90 plus theta. Cos of 90 plus x is minus sin x, and then this is the first order derivative, so differentiating with respect to x, cos f of x is minus sin f of x into f dash of x, but f dash of x is derivative of pi by 2 plus x, its derivative is 1, so again we are getting minus pi by 2 plus x. Now here again I will use the same formula, cos 90 plus theta. Okay, cos 90 plus theta is nothing but minus sin theta. Okay, so this pi by 2 plus pi by 2 is 2 pi by 2. Now again differentiating with respect to x, cos of f of x, its derivative is minus sine f of x into f dash of x. So here the derivative of 2 pi by 2 plus x. Now 2 pi by 2 is a constant, derivative is 0 and derivative of x is 1. So this again minus sine theta can be written as cos 90 plus theta. Now this is theta, this is theta, so pi by 2 plus theta. Again this pi by 2 plus 2 pi by 2, I can write 3 pi by 2. Okay, so the third order derivative is cos 3 pi by 2 plus x. Now the second order derivative is cos 2 into pi by 2 plus x. Third order derivative is 3 into pi by 2 plus x. So we can generalize the concept to find the nth order derivative. Is cos n times pi by 2 plus x. By this formula you can find the derivative of the given function. Any derivative, first order, third order, fifth order, sixth order, seventh order, 100th order, anything. Now we want to find the derivative of sine ax plus b. Again on the same line. As I told you, here also we will get alternately sine cos, but we have to stick up for only one function. So always the derivative, whatever derivative we are getting or we have got, that I will convert into the sine. So dy by dx is cos of ax plus b into dy by dx of ax plus b. Now its derivative is a. So and I cos of theta, I can write it as sine 90 plus theta. So sine 90 plus theta into a times sine 90 plus theta. Differentiate this with respect to x. What you get? A times cos pi by 2 plus ax plus b d by dx of pi by 2 plus ax plus b. Now again here the derivative is only a, and this cos of pi by 2 plus theta can be written as sine 90 plus theta. Sine 90 plus theta. This is theta full. So again pi by 2 plus pi by 2 is 2 pi by 2. A times sine 2 pi by 2 plus ax plus b, and here the derivative is only a. So this a and that a is a square sine 2 times pi by 2 plus ax plus b. Now we will again differentiate this function with respect to x. Now basic square is as it is, derivative of this sine f of x is cos f of x into f dash of x. So f dash of x means derivative of this 2 pi by 2 plus ax plus b. 2 pi by 2 is a constant, derivative 0. B is constant, derivative 0. Now derivative of ax is a. And now this sine 90 plus theta, this is now my this is angle, so I can write this cos of theta is sine 90 plus theta. Then a and a square is a cube, and this sine pi by 2 plus 2 pi by 2 is 3 pi by 2. So d cube by dx cube, d cube y by dx cube is a cube sine 3 pi by 2 plus ax plus b. So this is the third order derivative. So by generalizing, we can write the nth order derivative as dn y by dx raised to n is equal to a raised to n sine n times pi by 2 plus ax plus b. So this is the exercise 1.5. From that fourth type, we have to find nth order derivative. Now we will continue the same type of examples in our next lecture.